Hello, everyone, and thank you for attending today's webinar, a new way to analyze materials with APEX 2.1 software for EDS. Before we begin, I'd like to cover a few housekeeping items. At the bottom of your audience console are several application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget and submit your question. We'll try to answer these during the webcast, but if a fuller answer is needed or we run out of time, you'll receive an answer later via email. We do capture all questions. A copy of today's slide deck is available in the resource list widget that looks like a green folder. You can expand your slide area by clicking the maximize icon in the top right or by dragging the bottom right corner of the slide area. If you have any technical difficulty, please click on the help widget. It has a question mark icon and covers common technical issues. An on-demand version of the webcast will be available approximately 1 day after the webcast and can be accessed using the same audience link that was sent to you earlier or via EDAX.com. Now I'd like to introduce the presenter for today's webinar. Dr. Nalin Kalyan joined EDAX as an application specialist in February of 2020. Working out of the Weiterstadt, Germany office, she concentrates mainly on EDS support for the European market. Nalin's responsibilities include training and educating customers on EDAX products and software and helping customers resolve any issues they may have. She also represents the company at various trade shows and conferences. Prior to EDAX, Nalin worked as a PhD student at TU Darmstadt in Germany. She worked with Professor Dr. Barbara Albert while completing her PhD thesis on single crystal synthesis and characterization of manganese monoboride, as well as magnetism and hardness of selected metal borides in 2019. The opportunity allowed Nalin to gain experience using NSEM and EDS. She received a bachelor's degree in chemical engineering in 2013 and a master's degree in chemical engineering and inorganic chemistry in 2014 at TU Darmstadt. Now over to Nalin.
Thank you, Jonathan, for the kind introduction, and thank you all for attending the webinar where I will show you a new way to analyze materials with the APEX 2.1 EDS software. EDAX is located in the business unit material analysis in the AMETEK concern. You can see that AMETEK has many subgroups. Especially the business unit material analysis is in our focus because this division represents EDAX. We are working close together with the colleagues from CAMECA, AMTEC, and Vision Research. This cooperation has a background as some products of our detectors are designed and produced by them. Gatan is one of the newest divisions in the material analysis. They joined AMETEK in the end of the last year. Mainly, EDAX will gain from Gatan because they will cooperate and will work in many areas close together. This was just an overview for you to see where EDAX is located in the AMETEK family. We have a huge product variety of EDS, EBSD, and WDS products. The broad spectrum of the EBSD detectors with the revolutionary clarity, the world's first commercial direct detection system, the Velocity, our high-end speed camera, and the Hikari, as well as the DGView, one of our older systems. For the WDS technique, the lambda detector is used. The spectrum of the EDS technology is large. We operate the Octane Elite, one of our high-end products, which take the detector technology to the next level, and the Octane Elect detector with advanced technology and high-speed electronics. Furthermore, we are working with an Elect detector in compact package of a detector with maximized performance and flexibility. The system is called Pegasus if an EBSD and EDS system is used in combination. By so-called Neptune, an EDS and WDS are working together. If the detectors are used in combination, then the system is called Trident. We aspire for enhancing our devices and realize best requirements for them. So we are producing the innovative and best instruments for our customers. The steady improvement for our systems is in our interest and focus. So we are performing an ongoing process for enhancing fast EDS analysis with best data quality, high energy resolution, and high light element performance. How can we realize these specifications in our hardware? This is implemented by the CMOS technology, the silicon drift detector, the ultra-thin ceramic window, and the extensive chip as a best quality data processing. The fast data processing is possible with the 64-bit multi-core processor, which allows the simultaneous data collection and review of them. Now we can go over to the topic of today's webinar, our software. But first, the question, how is the electron microscope communicating with the EDS system? As seen here on the screen, the beam and stage has to be controlled by the software as well as by the electron microscope. This means the information of the stage position and the energy of the beam has to be known by the software. This is done by the digital pulse processor and the scan generator. After a calibration of the beam and stage control, the software is ready for use and the data collecting can be realized. The network of the interaction between electron microscope, detector, and PC is shown in this slide. The data are collected with the detector, are forwarded to the DPP box, where the processing and analyzing happens, and are passed then to the APEX software once they were analyzed and edited. Here is the heart of the system. In this slide, the front side of the detector is imaged in its single parts. In addition to the collimator, we have the ultra-thin silicon nitride window with a supporting grid, and the chip of the detector, which is placed on a substrate. The electronic is cooled with a Peltier element. This module is vacuum-tight, so any additional absorption is not possible. The processing of the measured X-rays depends on the detector type and the speed of the electronic. The ceramic window has a high transmissivity and ensures a high amount of low-energy X-rays. These compounds are relevant for the processing of the treated X-rays, so a detailed look into these elements is necessary. One innovation of the detector system is the ultra-thin ceramic window, consisting of silicon and nitrogen. Commonly, polymer windows are used for EDS detectors. Significant differences and disadvantages of the polymer window in comparison to the silicon nitride window is the thickness of the window, the aspect ratio, the thermodynamic stability, and the physical resistance. Advantages of the ceramic window is the increase of light element transmissivity due to the thickness of the material, which is below 100 nanometers. Thus, the transmission of nitrogen rises to 60% compared to the polymer window with 30% transmission. The thermodynamic stability of the ultra-thin window is affected in compatibility with plasma cleaning for using FIP and in low vacuum mode. The physical properties are also an advantage for using the ceramic window. After the X-rays passes through the ultra-thin silicon nitride window, they reach the silicon drift detector. These information are measured with the SDD and are then analyzed with the CMOS, the complementary metal oxide semiconductor electronic. I have to mention that the application of the CMOS technology increases enormously the processing speed and ensure coincidentally the best energy resolution. Here we can see the single elements of the electronics with the STD, CMOS preamplifier, and the two-stage Peltier cooling. The sequence and the ideal design of the electronic increases the count rate within the energy resolution and enable the low noise and fast analyze of data. Today, I am using an Octane Allied EDS detector, and on this slide, some specifications of this high-end detector are listed. The high efficiency of the electronics, as I told in the slide before. Improvement of the pile-up rejection and reduce of some peaks, providing of carbon detection with a high resolution, automated EDS parameter optimization, and allowing a high-quality data collection are a part of the new technology of the detector. This was a general overview of the EDAX EDS world. Now I would like to go through the APEX software and do this on the live system. I will present you how the data collection and the qualitative as well as the quantitative analysis is working. From this version on, APEX is a full integrated Pegasus system. This means the integration of EDS and EBSD in one software. We can use this software for our EDS analysis as well as for our EBSD diffraction images. You can see this in the upper right, so I can switch from EDS to EBSD. This has a huge advantage as the operation for only one software is required to use two different analysis methods. At this point, I would like to mention that not all features that I will show you now are included in the packages. We have two different packages, the standard and the advanced package. So if you want to buy the standard APEX software package, you have to think about which features or which functions are relevant for you, and if your requirements if the requirements are then done with the standard package, or if you go up to the advanced package. Another option is to buy the standard package and add some relevant features to it. This is also possible. Here you can see the user interface of the software. It is clear and well structured, as well as it is not too overloaded. This structure of the surface is an intuitive working place without larger previous knowledge is needed. You can freely choose the window. Freely choose a window and set it to one other area. So it is individually and customized. So we can also go over, like that. So we can also go over and see that we have some templates for the user interface. So you can select this template, or you can do it on your own and optimize and customize your user interface. I will go systematically and show you at first general functions or general options of the software. So as you can see here, this is the name of the account I am using. And when you click on account, then the general options pops up. So you can see the naming of the account. By clicking on info, you can see which functions are included in the software. You can see which version you are using. And you can also do an update by your own. So if you go on check updates, you can update your Apex software. By the tab options, you can customize again your surface, so you can set your own logo. You can choose and name the location where you want to save your images you're saving or you're doing on the software. So you can also select the image type, and you can rename or name the images you are saving with a prefix. So we are able to choose number, date, default, or project as prefix for the images we are saving. We are also possible to get another look for the user interface. So I have now selected gray, but we can go over to light. And here we can, in the next button, we can choose or select the location where we want to save our Apex H5 files. Apex is using for storing H5 data because we have very large amounts of information. So the H5 format satisfies our expectations, and for this reason we are using H5 files for our analysis or measurements we are storing. And left in the box, we can select the tab language. We're able to use the software with 7 different languages. In this tab, we can select the parameters we want to see in the bottom. So we can click on some parameters we are interested in. And when we click on OK, the parameters will be shown in the bottom. In the tab Administration, we are able to activate the multi-user mode. So the user is able to work with the software with different people. So by clicking OK. Okay, so we can see here. Okay, we can see here the different tabs for the different analysis methods. So we can go to the different methods by clicking on the tabs. By clicking on the A in the left corner, we can open our project tree, for example. And you can see here the name of the project and the subgroups in this project. So all the data you are measuring in the software are stored in the project tree. So when you want to create another subgroup in Apex, it is called sample. Then you go over to sample, type in the name of the sample and go on OK. So when the sample or the subgroup is highlighted red, then this sample or this subgroup is active. All the measurements you are doing will be stored in this subgroup. So by clicking or by doing a right click, you can delete or rename the sample, or if you have done measurements in this, or I will go up. So if you have done measurements on it, then you can go here and delete, for example, some of the measurements you have done because of some reason. So then I will begin to show you the features or the functions in the spectrum analysis method. So by clicking on Collect Image, we will get the image of the SEM. So, and you can see here we have the main part is separated in boxes, I will say. And this is the acquisition box, and the spectrum box, the quality box. And we have always this arrow on the right bottom in the edge. So by clicking on that, you will always get some more information about this acquisition box or about this box. So as I have mentioned that I will use the Allied detector, and the Allied is motorized, so I will click on Move In, so the detector will move in. And if we go here to column, we can see that the parameters of the SEM is on the software side also seen. Also, the stage parameters are located here. So we can see that the detector is inside or is moved in. The detector is ready, is cooled, so everything's fine. As we have this spectrum box, we have two different possibilities to make to analyze a spectrum. So with the survey mode, when we activate the survey mode, we can do measurements, or we can analyze a spectrum without saving the data in the project tree. It means when I go on, or when I select an area, the detector will collect a spectrum, but the data won't be saved in the project tree. By clicking on this red dot, we will stop the acquisition, and nothing will be stored here. So when we go on and select an area and do some spots, we can also go over to this box and can choose the free draw mode. It means we can make a free draw, and we are able to do grid. So I will choose an area and can set or configure the points. So I can select 5 to 3, and when I confirm, then this grid or the spots will get here. So what we also can do over this A, we can open the scan list. The scan list is the list where all the points, areas, and free draw we have set on the image is stored here. This means we can delete some of the points or the spots when we are not happy with them. We can delete all of the setted points, or we can go to the image. And if we go up to this spot highlights, and by clicking on it, we'll get rid of it. So I will click on delete all. We'll set some normal. We'll set some spots and an area. And by clicking again on this arrow in the edge, we can see which background method we are using. We can configure our ID sensitivity with this bar. We can choose auto MDL. MDL is minimum detection limit. We can select the label details. We can also go over to process and activate the pile up distribution. We can do shift corrections and can see the 5 parameters of this measurement. When we go on quality, into the quality box, we have again templates we can use, or we can go to manual and set the parameters for the spectrum measurements by our own. Again, on the edge, I will choose 20 seconds for one spectrum, and I will define the amplifier time. The amplifier time is the rise and fall time of the X-ray pulse. So the higher the amp time is, the better the resolution. So, but we have to be careful that the dead time will not be above 30%. So I think the amp time with 3.84 is good enough. We have 7 different amp times we can choose by clicking on OK. By clicking on OK, this options or this predefined parameters are saved. And when we click on Collect, the software will begin to analyze. During the acquisition, we can do changes on the spectrum. This means we can go here and add an element. Or we can get rid of some elements during the acquisition. So, and when the areas we have predefined are highlighted red or popped up, this means the active measurement is here. So now, again, we can add an element. So, and it will, we can also, so we can also go to this red stop button and stop the acquisition. You can see how long, in this bar, you can see how long the measurement will take place. And during the spectrum analyze, so the qualitative measurement, simultaneously the quantitative analysis is also going on. So we are now at the last spot, the last measurement. It's now finished. So we can see in the project tree that our measurements are stored here. So we can open our measurements, our single measurements by clicking on the single measurement, or we can click on the sample. So all the measurements in this subgroup will open then in an overlay. So we can, so this is the measurements we have done before. On the left side, we have the quantitative results of the spectrum. So by right-clicking on the spectrum view, we have some hidden options. So we can go over and, for example, explode this spectra to have a better view of them. So we have now all single spectra we have opened. We can do changes on them. So we can fit the background. We can get rid of elements if they are not fitting. We can add some elements. So, or we can only open one spectra. So you see on the SEM image, the area we have, we did the measurement or the analysis. So we can do a right click and go to background and see that the background is active. So we can see the background plotting or the background curve. And when we go on view regions, we see where the regions of the background fitting is. We can manually fit also the background by clicking on display. So if the background of the spectrum is so yellowish, then you can fit your background by clicking on. So by right click again, you can see that the deconvolution is also active. You can change the color of the deconvolution. By right-clicking again, you have the option of the element ID, means you can activate the sum peaks, the escape peaks. You can do some changes in the label sensitivity or in the label details. When you go on spectrum label, you can go to 13, 14 and make the labeling of the elements bigger. You can change the color of the primary color of the spectrum, and you can also save this spectrum as image by clicking on Send to Folder. By clicking on Send to Folder and then opening the folder, this is shown here in the project tree. The folder will open and you will get 4 different file types as the program is saving the spectra as SPC file. This is an Apex special or Apex own file, and as PNG, as MSA, and as CSY. So by clicking on PNG, you can see that the spectrum is saved as PNG as image in the folder. So we have also some options on the left in the spectrum view. So when you maximize, for example, one peak by hold and right-clicking, and you want to go to the home view, you click on the first box. And when you want to customize the scaling, then you can go to manual and type in how the scaling should be, because the software is doing this automatically, but you can also customize your the view of the spectrum. So by clicking on the third box, you have the option, or the window with the periodic table will open, and you can select elements from the periodic table. You also have the option in this hidden window to open the window and activate the elements you want to use for the quantification. This means if you do not quantify manganese and iron in your sample, then you can disable the two elements, click on OK, then you will get rid of them in the quantification. So by clicking, I will click on OK. By clicking on this box, this is again the box which you can also see when you make a right click. This is the window where you can fit the background regions. By clicking on this box, you will refresh your quantification results. This means if you do some changes on your spectra, if you get rid of an element, if you do some fitting on the background, then you have to click on this, that the quantification results will refresh. By doing changes on the spectrum, for example, by getting rid of silicon, this box will get purple. And by clicking on this box, you will save the changes on your spectra. So by reopening the spectra in 2 days or so, the change will be there. So it means that the silicon will not be in your spectrum. But if you do not save the changes, your silicon will be in your spectrum. But in this case, silicon is inside, so I will edit, save. So and this box is also available with right-clicking, is the send to folder and save as box. So you can save the spectrum as PNG file or as image, and you are able to do it also directly in Spectrum View without right-clicking. So the quantification, the quant results window, so where your quantification results are shown. You can see here the elements, the line which is quantified, and the weight percentage and atomic percentage. MDL is, as I mentioned, the minimum detection limit. And by clicking on the line, you can select or you can choose the line which should be quantified. By clicking or by doing a right click, you can optimize or you can get rid of some parameters which are not in your interest. If, for example, MDL is not in your interest, then you can deactivate MDL. By clicking on Option, you will get you will see your options which are possible to use. For the quantifications, we are able to use two different quantification methods, the EDSAF and the PBAT-SAF, the peak-to-background SAF. We are able to use SCC factors, so standard factors. We are able to define a carbon code, so we can click on Auto, so the software will automatically define the thickness of the carbon code, or if you know the thickness of your carbon code, you can go on Manual and type in what the thickness is. We have also the possibility of oxide ratios. This means we can quantify the oxides in our sample. And the Tools button, I will open again the 4 different spectrum. So then it is easier to show what the toolbar is doing. So we have the possibility by clicking on the toolbar to see our quantification results in a graph. We can select the spectrum we want to see as a graph, or we can click on Statistic and can see the different values of the elements in one statistic graph. So I can go to aluminum and click on aluminum, and I will see the different weight percentages of the different spectra. So we go to silicon, manganese, and you can also save this graph as image by right-clicking and send to folder and clicking on send to folder. So if everything is fine and you did your changes on the spectra and the quantification fits, you can create a report. And we have 1, 2, 3 different ways to create or generate a report. We have the quick report option. We have the selectable report option where you can define what should be in your report. And we have the advanced report function where we have, again, different templates, and where you have the option to choose the designer mode, where you can create your own template for the reporting and use this for the reporting function. So we are now, as you can see, in the review mode. And to go on again to the live mode, I click on EDS. Then I will go over to the live mode and can do some measurements. As you can see here, we have some other boxes. We can enable the drift correction. We have the function of the batch mode. And the dual detector mode means that we can use 2 different detectors at the same time and can merge the spectrum or the spectra. So this was a general view of the spectrum analysis method. So by clicking on the line tab, we will go over to the line scan. I will close the project tree. By drawing a line, we can again go over to the quality box and define our parameters. So we can do it by defining the line scan with points or with the resolution. We can set points, 16 frames, and the dwell from 100. And we also have to adjust the amp time. And by clicking on OK, this parameters will be saved. So we have also a chance to define the line data type, where we have the option between region of interest, the net line scanning, the atomic, and the weight percentage. We are also able to activate the drift correction in the line scan, and we are able to use the batch mode, where we can do measurements on different samples, where this positionings or these positions of the different samples are saved in the scan list. So when we now activate the batch mode, make a line scan, and go to another position on our sample, for example. So I will remove now a little bit on my sample. And when I click again on select an image, and I will do the line scan here. And when I open the scan list, so now I have now the first line scan here on this image. And when I go to another position and select another line on another position, then it will be saved here, and we can do the measurement on different positions via the batch mode. So I will take this line data, and we are able to change the color of the line axis, and we can change the colors of the elements. So when I do this, go select, we can confirm the elements after preview. So I can add some elements, go on OK, and the software will now do the line scan. And during the line scan, I can go to the review mode and can do some changes, for example, for my spectrum, which I did before. And the measurement will, the acquisition will go on. And you can see here in the bar that the remaining time are 6 seconds. So the measurement is going on. You can do some look for close and again quantify, because we did a change. And the quantification should be refreshed. So we can see now on the bar that the line scan is done. And by clicking on EDS, we will move to the live system and can see our line scan and the spectrum and the quantification. So here we have all the elements, and by disactivating or unchecking, for example, the nickel or the iron, they are not displayed then in this line scan. So if I only want to compare, for example, silicon and manganese, then I have to uncheck all the other elements and can compare then the two elements. By right-clicking, we can save this image, and we can send it to the folder, as I have showed before, and we can save this. We can smooth this lines or the measured lines, or we can manually, automatically scale our axis. So by right-clicking, by left-clicking on fixed, we can type 16, for example, in, and we can see that the axis will take the value we have entered in. We can also generate a report, and we can do some recalculations on the line scan by opening the line scan in review mode. You can see that we have the option for rebuilding the line scan. This means I had clicked atomic percent for the line scan, and if I now want to see the line scan as region of interest, I click on region of interest, click on rebuild, so the software will recalculate and will image the line scan as a region of interest scaling. So these are the elements. Click OK. We'll rebuild, so we can simultaneously go over to the live mode and do a mapping, for example. So when I click again on select an image, what you can see here is a montage imaging view. This means the software is able to image a larger area. So you define the area, and the software is automatically generating the fields of this area, and you can then do the mapping field by field, and the software will then stitch the fields and show you the mapping of the large area you have defined. So I will just get rid of this. This is now the image I have collected. Again, with the quality box, I can predefine or define my parameters for the mapping. So I will say 16. I will just, yeah, now it's right. Here you can see the time for the mapping. By clicking on OK, you can activate again also in the mapping analysis method the drift correction. You can choose the element colors. You can activate the batch mode. You can also activate the compo maps. The compo maps is a function where you can separate the qualitative and quantitative maps. You can image your region of interest maps and your net maps. And this is a possibility for separation the elements of overlapping peaks, for example. By clicking on collect, the mapping will start. And we will be asked again if we want to confirm the elements. So we say yes. Niobium, aluminum. And when I click on OK, the mapping will start. Here we have the single maps. You can see the single maps above. And at the bottom, we see the phase maps. The system or the software is automatically generating phases, and these are displayed in the phase map view. So by clicking on the single maps on the right, you can overlay the different single elements, single maps, and can compare them, for example. Or you can click on overlay, and you will see the overlay of all elements you have chosen. And after this mapping is done, you also can generate a report. You can save the single images. You can overlay 2 or 3 different images and can save this. And you can also save this data, or the phase, or the phase maps. Also, yeah, you can also save them. Yeah. So you can see here that the bluish regions are chromium, iron, and nickel. And by clicking on this blue box, you can see the single maps of the phase. And by right-clicking, you can extract the spectrum of this phase. Okay, the mapping is done. You can combine phases if 2 different phases belong together. Then you can combine the phases. You can select a color, or you can rename this phase. What you can also do is, so I will come to the end, what also possible is when you open the map, when you see the overlay mapping, you can also select an area in the map and can see the spectrum of this region, for example. So you can see here that the red curve is the spectrum of the whole area, and this greenish one is the spectrum of this selected area. You can also go here and have a look on this range and compare it to the spectrum of the whole area. So this was the end of the presentation of the APEX software. Thank you very much for your attention. The questions will be responded via email. And from my side, thank you a lot, and have a nice day.